this video, we're going to continue the discussion on inverse functions, and we're going to apply it to how we determine whether two functions are inverses of each other, or verifying that we know they're inverses, but proving it by using a verification. So our objective here is that we can verify that functions are inverses. So first of all, to verify inverse functions, you show that f of g of x equals x and g of f of x equals x. What you're in essence doing is showing that when you do the composition that they undo each other. So the key idea here is use composition of functions. Now, this is the formal way to do it. There is an informal way. If you're trying to show, for instance, these two functions are inverses of each other, you can informally take this one function, find its inverse, and verify that it matches this one. So find the inverse of one function and see if it matches the other. So let's go ahead and we're going to use the formal method for this one, okay? So the formal method is we're going to do both f of g of x and g of f of x. You have to do both and then see if that equals x. So let's start with f of g of x. Remember composition functions for f of g of x. You take the first function, where there's an x, you put a parentheses, because that's the input spot. And in that slot, we're going to put the other function. So we're going to put this function here. And then you have to show some work to verify that these two are the same. So you go ahead and multiply 3 times 1/3 x, and you get x. 3 times -3, and you get -9, plus 9, and notice that equals x. So whatever we put in to this function, whatever x value we put into this function, get out the result and put it into this function, it will undo it and give us back the original. Let's just check to see what that looks like, just to show what this looks like. Let's say our x is equal to 18, okay? So if we take 18 and we put 18 in here, 1/3 of 18 is 6, 6 minus 3 is 3. Put that 3 that results into here, 3 times 3 is 9, 9 plus 9 is 18, we get out the original. That's what this is showing, is that works for every single x, that if we plug it into that one, and then we plug the result into there, we get the original. Now you do have to do it for the other, so we're going to do g of f of x. So this means we go to the g function this time, and where there's an x, we put a parentheses, and in that parentheses we're going to put the other function, so the second one, the inside one, and we multiply that through. 1/3 times 3x is just 1x, 1/3 times 9 is 3, and then we have our -3 here. The 3 minus 3 get rid of each other, and you just get x. It's verified. Okay, so we have that these two are inverse functions. We know that they are. We verified they are. This is like a mini proof of it. All right, now here's a different question. This question could be asked: determine whether these two are inverses of each other. Okay, so if you're trying to determine if these two functions are inverses of each other, you can use composition and see if you get x out. If you don't, then they're not inverses of each other. Okay, so let's try these two. We're going to do h of r of x. Let's try that one. And so we're going to take the h function, take the x out, and we're going to put this in its place. We get 1/4 x minus 20. Now we multiply through. 4 times 1/4 x is just x. 4 times -20 is -80. plus 20. Notice that gives us x minus 60. We do not get just x out, so these are not inverses. If you got that they were if you got out just an x, and then you did the other one, r of h of x, then you would have verified that they are inverses. Okay, so two questions. One, verify. Can you verify or verify that two functions are inverses? When we do that, usually they already are inverses, and you're just verifying it by proving it, doing f of g of x and getting x, g of f of x getting x. You gotta do both with the composition. And then the other one is asking the question, are they inverses? And the way to do it is you go ahead and do your h of r of x here. We did not get x, so they're not inverses. The other way is the informal way, is take one of the functions, find its inverse by going through the step-by-step process, and if it matches the other, then they are inverses.